Andhra Pradesh Public Service Commission Government Polytechnic Lecturer Examination 2020 ECE Question Paper Solutions Part 2. Question number 51. The wave impedance of a medium is equal to. So the wave impedance of free space divided by refractive index of the medium. Correct option is 2. So we know that wave impedance is a ratio of electric field to magnetic field in a propagating wave. For a plane wave impedance in free space is 120 pi or 377 pi. So in terms of refractive index, so the definition of refractive index is speed of light in vacuum to speed of light in a medium. The velocity of EM wave propagating in any medium is given as phase velocity Vp is equal to c by square root of mu r epsilon r. And the refractive index, relation between refractive index and permittivity is refractive index is equal to square root of epsilon r. So refractive index is square root of epsilon r. We know that wave impedance eta naught is equal to square root of mu by epsilon r. So mu r can be treated as 1 because non-magnetic medium. So medium of the not mentioned, hence assume it as non-magnetic medium. For non-magnetic medium, mu r can be treated as 1. So eta is equal to eta naught into 1 by square root of epsilon r. So 1 by square root of epsilon r can be written as refractive index. Therefore, intrinsic impedance in free space divided by refractive index. So wave impedance of a medium is equal to wave impedance in free space divided by refractive index of the medium. Correct option is 2. Next question. Consider the interface between two dielectric materials. So if there are two dielectric materials, that is dielectric boundary. This is a dielectric boundary where for medium 1 relative permittivity is epsilon 1, for medium 2 permittivity is epsilon 2. In dielectric interface, the tangential component of electric field is continuous. The tangential component of electric field and normal flux density both are continuous. This means Et1 is equal E1t is equal to E2t, E1t is equal to E2t, and D1n is equal to D2n. As per the question, Et1, the tangential component of electric field in medium 1 is 10 volt per meter. What is the tangential component of electric field in other side? So what is, in the question it has been asked, what is Et2? Therefore, for dielectric interface, Et1 is equal to Et2. Et2 value is 10 volt per meter, same as Et1. Correct option is 1. Next question. Question number 53. Vector potential is a vector dash. So we know that A is a magnetic vector potential in electromagnetic fields. B is equal to, relation between magnetic flux density and vector potential is B is equal to del cross A. That is the curl of vector potential. The curl of magnetic vector potential is called magnetic flux density. And one more thing is del cross E. Curl of electric field is minus dou B bar by dou T, and divergence of electric potential, that is del dot D, is rho V, or del dot E is equal to rho V by epsilon, and the pointing vector is P is equal to E bar cross H bar. So, vector potential is a vector whose curl is equal to magnetic flux density. Correct option is 1. Next question. A line is said to be distortionless. The condition for distortionless line is Lg is equal to Rc. So for distortionless line, characteristic impedance Z0, phase velocity Vp, alpha, attenuation constant are independent of frequency, which can be realized as R by L is equal to G by C, that is Lg is equal to Rc. The transmission line is said to be lossless if R is 0 and capital G resistance per unit length is 0 and conductance per unit length is 0. So the condition for distortionless transmission is Lg is equal to Rc. Next question. The beam width between first nulls of uniform linear array consisting of n equally spaced elements and the elements are separated by distance d equally excited is determined by. So beam width between first nulls or first null beam width in a uniform linear array of n equally spaced and equally excited elements is approximately given as beam width first null is equal to approximately equal to 2 lambda by nd, where lambda is a wavelength, n is the number of elements, d is the spacing between the elements. So it is determined by the product of n into d, as well as it also depends on wavelength lambda. So correct option is 4. Question number 56. An antenna when radiating has highly directional radiation pattern. The same antenna when it is receiving, what is a radiation pattern? So antenna reciprocity theorem states that according to the reciprocity theorem of antenna, if antenna can transmit a signal in a particular direction with a certain pattern and polarization, then it will receive the signal equally well from the same direction with same pattern and same polarization. So that is correct answer is 3. The properties of antenna, the characteristics of antenna such as radiation pattern, gain, impedance, polarization are same whether it is used for transmitting or receiving signals under same conditions. Next question, the frequency range of satellite communications. So generally the satellite communication frequency range is from 1 gigahertz to 40 gigahertz. Here the correct option is for 1 gigahertz to 30 gigahertz. These are the bands used in satellite communication: L band 1 to 2 gigahertz, S band 2 to 4 gigahertz, C band 4 to 8, X band 8 to 12, Ku band 12 to 18, K band 18 to 27, Ka band 27 to 40 gigahertz. These are the bands used in satellite communication from 1 gigahertz to, or it can also be written as 1 gigahertz to 40 gigahertz or 30 gigahertz. Correct option is 4. A medium wave radio transmitter operating at a wavelength of 496 meters has a tower antenna height of 124 meters. What is the radiation resistance? So radiation resistance for Hertzian dipole or short dipole, radiation resistance is given as 80 pi square dl by lambda whole square. So that is 80 into pi square. Length is, height of antenna is 124 meters and wavelength is 496. In the question, length of antenna is far less than lambda. So that is it's a Hertzian dipole. Hertzian dipole. So here length of antenna is 1 by 4 times of wavelength, 0.25 times of wavelength. So for Hertzian dipole, radiation resistance is 80 pi square dl by lambda square. Substitute the values of length and wavelength. 80 pi square, so that is 1 by 4 square. So on calculation, its value is 5 pi square. So 5 pi square is approximately equal to 50 ohms. So radiation resistance of given antenna is 50 ohms. Correct option is 4. Next question. Two lossy lines are joined end to end. The first line is 10 meter long with a loss rating of 0.2 dB per meter. So for transmission line 1 having a 10 meter length and attenuation of 0.20 dB per meter. Similarly, it is connected to a other transmission line of length 15 meter and with 0.1 dB per meter. The reflection coefficient at the junction is 0.3. So reflection coefficient at the interconnection point is 0.3. Now if the input power is 100 milliwatts, in the question asked, determine the total loss of combination in dB. For a given transmission line 1, total attenuation in transmission line 1, total attenuation in line 1. For line 1, total length is 10 meter and the attenuation per meter is 0.2 dB, that is 2 dB. Total attenuation in line 2, transmission line 2, its length is 15 meter and the attenuation is 0.1 dB per meter. Its value is 1.5 dB. Now attenuation due to the reflection coefficient. So this mismatch loss, it is termed as mismatch loss. Return loss is 20 minus 20 log of gamma dB, whereas mismatch loss is minus, it is given as minus 10 log of 1 minus gamma square. This is the mismatch loss. So now the mismatch loss in transmission line is 10 log of 1 minus gamma square, given gamma is 0.3 whole square. On calculation, its value is 0.4095 dB. So approximately it can be written as 0.41 dB. Now, due to reflection coefficient or mismatch loss, is 0.41 dB. At total attenuation due to transmission line is 1 is 2 dB, total attenuation due to transmission line 2 is 1.5 dB and the mismatch loss is 0.41 dB. Now the total attenuation is 2 plus 1.5, 3.5 plus 0.41, that is 3.91 dB. So correct option is 1. Next question. Skin depth of copper at a frequency 3 GHz is 1 micrometer. For copper at frequency 3 GHz, skin depth delta is 1 micron. At 12 GHz, for a non-magnetic conductor, for other material, frequency given is, so let us assume it is F1 delta 1 for copper and F2 12 GHz. So we need to calculate the skin depth in the given non-magnetic material. Let us assume sigma is the conductivity of the copper, sigma 2 is 1 by 3 times, conductivity is 1 by 3 times of conductivity of copper, sigma C by 3. We know that the skin depth delta is given as 1 by square root of pi f mu sigma. Now this delta is proportional to 1 by square root of frequency into conductivity. So delta 1 by delta 2 is square root of f1 sigma 1 by f2 sigma 2. F2 sigma 2 f1 sigma 1. Delta 1 is 1 micron, delta 2 f2 is 12 gigahertz and its conductivity is 1 by 3 times conductivity of copper, f1 is 3 gigahertz and conductivity is sigma c. Now delta 2. Skin depth in a given non-magnetic conductor is square root of 3 by 4 microns. So correct option is square root of 3 by 4. Next question. The wavelength of wave propagation constant is 0.1 pi plus 0.4 pi meter inverse. So propagation constant is given as alpha plus j beta, where alpha is attenuation constant, beta is a phase constant, which is given as 2 pi by lambda. So this phase constant given is 0.4 pi. 0.4 pi is equal to 2 pi by lambda. From here wavelength is 2 pi by 0.4 pi, that is 1 by 0.2, which is 5 meters. So wavelength is 5 meter. Next question. An uniform plane wave in an air, that is medium 1 is an air, impinges at 45-degree angle on a lossless dielectric with dielectric constant epsilon r. For medium 1, relative permittivity is epsilon r, and the transmitted wave propagates at 30 degrees. Here theta 1 is 45 degrees and theta 2 is 30 degrees. What's the value of epsilon r2? So medium 1 is given as air, so epsilon r1 is 1. Apply Snell's law. Refractive index n1 sin theta 1 is equal to n2 sin theta 2. So we know that refractive index, the relation between refractive index and permittivity is, refractive index is square root of permittivity. So that is square root of epsilon r1 sin theta 1 is equal to square root of epsilon r2 sin theta 2. Here theta 1 is 45 degrees, 1 into sin 45 is equal to epsilon r2 sin 30. Sin 45 is 1 by root 2, square root of epsilon r2 sin 30 is 1 by 2. Now root 2 is square root of epsilon r2. Epsilon r2 value is 2. Correct option is 2. Question number 63. Given a ferrite material with magnetic flux density is 0.05 Tesla, assuming mu or 50, calculate the approximate value of magnetization M. We know that B is equal to mu naught by B is equal to mu naught into H plus M, where magnetization M is equal to B by mu naught minus H. So the value of B is 0.05. Mu naught is 4 pi into 10 power minus 7, and magnetization value H is 50. So here it is not mu r, in the question it is H. Magnetization H is 50. We know that mu naught value is 4 pi into 10 power minus 7. So on calculation its value is 39,788.73 minus 50, that is 39,738 0.73 approximately equal to 39,000. So magnetization value M is 39,000 ampere per meter. So correct option is 2. Magnetization. So let us see the note point here. Magnetization is a material response to external magnetic field, and this equation consists of two parts, that is field due to external sources H and the field contributed by the material's own magnetization. Next question. Question number 64. Find the maximum torque for a rectangular coil. So the torque on a coil placed in the magnetic field is given by torque tau is equal to NBAI into sine theta, where theta is the angle between normal to the coil and magnetic field, and the torque is maximum when sine theta is 1, that is theta is 90 degrees, when the plane of coil is in parallel with the magnetic field. Here N is the number of turns in the coil, B is the magnetic flux density, A is the area of the coil, I is the current flowing through the coil. In the question, torque maximum when theta is 90 degrees, that is NBAI into 1. NBAI. Here number of turns is 85, magnetic flux density B is 6.5 Tesla, and the current carrying through the coil is 2 amperes. Area of the coil is 0.2 meter by 0.3 meter, that is 0.06 meter square. Substitute the values in the given formula. In the formula, 85, magnetic flux density 6.5, area 0.06, and current is 2. Now the torque maximum is 66.3 Newton meter. 66.3 Newton meter. Next question. So this question is deleted from the question paper. Given G, vector G is 3xy square ax cap plus 2z ay cap, and the initial point P is 211, xyz is 211, and the final point is 431. We need to find the integral g bar dot dl bar using the straight line y is equal to x minus 1 and z is equal to 1. So second step is, let assume that x is equal to t. X is equal to t, and keep if x is equal to 2, then y is equal to t minus 1, z is equal to 1. As x changes from 2 to 4, therefore t also changes from 2 to 4. Now the unit vector L is x ax cap, y ay cap, z az cap, x is t, y is t minus 1, and z is 1. Therefore dl by dt is ax cap plus ay cap. After calculation, dl by dt will become ax plus ay cap into dt. Now replace the values of x, y, z with t minus 1, comma 1 in the given expression g. Then g bar dot dl bar is 3t t minus 1 square plus 2 into dt. Integral, and then start integration from 2 to 4, because x starts from 2 to 4, t starts from 2 to 4. After integration, the value of g bar dot dl bar from 2 to 4 initial point to final point is 90. The value of integration is 90. Correct option is 1. Next question. A lossless transmission line of 80 cm long operates at 600 MHz. The line parameters L is inductance per unit length is 0.25 micro Henry per meter. Capacitance per unit length is 100 picofarad per meter, and the transmission line length is 80 cm long, that is 0.8 meters, and the frequency of operation is 600 megahertz. 600 megahertz. we need to calculate the phase constant and phase velocity. Phase constant beta is omega root LC, that is 2 pi, omega is 2 pi f 600 into 10 power 6 square root of L into C. L is 0.25 micro 10 power minus 6 100 pico 10 power minus 12. Now beta value is 6 pi radian per meter, that is 18.8495 radian per meter, and phase velocity Vp is omega by beta. Omega is 2 pi f, frequency is 600 megahertz by 6 pi. So from this, phase velocity is 2 into 10 power 8 meters per second. So correct option is 1. A signal f of t is said to be even signal. For even signal, f of t is equal to f of minus t, mirror symmetry about vertical axis. For odd signal, f of t is equal to minus f of minus t, rotational symmetry about origin. A signal f of t is said to be even signal if f of minus t is equal to f of t. Correct option is 1. A signal is said to be periodic if f of t is equal to f of t plus or minus nt. So that is, the signal repeats itself at regular intervals over the time. So when we integrate a unit step function with respect to time from 0 to infinity, so integration of unit impulse function is step signal, and integration of step signal is ramp signal. Similarly, integration of ramp signal is parabolic. So here integration of step function is unit ramp function. Next question. In a linear circuit, when AC input is halved, then what about the output? So we know that a system or circuit is linear if it satisfies the principle of superposition as well as principle of homogeneity. Principle of homogeneity states that if input is scaled by a times, then output is also scaled by the same amount, that is a times. So here input is halved. Input is half. For a linear circuit, output is also get half. Output will become half. So correct option is 3. Linearity is defined as the principle of superposition and principle of homogeneity. So principle of superposition states that the response to multiple inputs is the sum of responses to each individual input, and principle of homogeneity states that scaling the input by constant factor results in output being scaled by the same amount. So if the system is linear, then it has to satisfy both homogeneity and additivity, that is superposition and homogeneity. Next question, question number 71. Which of the following signal is odd signal? So sine signal is odd signal. Odd signal multiplied with odd. Odd signal multiplied with odd signal is even signal, and cos signal is even signal. So sine 100 pi of minus t is minus sine 100 pi t. So that is f of minus t will result minus f of t. So correct option is 2, which is an odd signal. Or we can also write as f of t is equal to minus f of minus t. Next question. Which of the following is not a dependent electrical energy source? This voltage source and current sources are independent independent energy sources, whereas voltage controlled voltage source VCVS, voltage controlled current source, current controlled current source, current controlled voltage source, all are dependent sources. So here, which is not a dependent electrical source means correct option 1, voltage source or current source. What is the characteristics of ideal voltage source? This ideal voltage source is characterized by zero internal resistance, that is no voltage drop exists within the source, and the source can supply any amount of current without voltage reduction. Similarly, ideal current source is characterized by infinite internal resistance. Here the correct option is 1. The characteristics of ideal voltage source is zero series resistance. Two resistors RA and RB combined give a combined resistance of 2 ohm when they are connected in parallel and 9 ohms when they are connected in series. That is RA plus RB is 9 and parallel connection is RA RB by RA plus RB, that is 2 ohms. Now we need to calculate the value of individual resistors. RA RB is 9 into 2, that is 18 ohms. So equation 1, equation 2, from equation 1 and 2, RA RB is 18 ohms, that is equation 3. We know that from equation 3, RA is 18 by RB. Substitute this in equation 1, 18 by RB plus RB is equal to 9, 18 plus RB square minus 9, RB is 0. On calculation we will get RB is 6 ohms or 3 ohms. If RB is 6 ohms, then RA is 9 minus 6, 3 ohms. If RB is 3 ohms, then RA is 9 minus 3, 6 ohms. So RB either 3 ohms or 6 ohms, RA is 3 ohms or 6 ohms. Therefore correct option is 2. Next question, the energy expended in the resistor R when a current I flows through it for a second time t is. We know that power dissipated in a resistor is voltage into current, that is I square R or V square by R. Now energy is power by time. Energy is power into time. Because power P is work done per time. Power is I square R into T. Now energy dissipated in the resistor R is I square R T. Correct option is 1. Next question. A 4 ohm resistance having a current of 1 ampere. What will be the power dissipated? So power dissipated is I square R. Current is 1 ampere and resistance is 4 ohm. Therefore total power dissipated is 4 watt. Question number 77. An ideal voltage source will charge an ideal capacitor. Given ideal voltage source. For ideal voltage source, it is having 0 internal resistance. Similarly, ideal capacitor is given. So for ideal capacitor, it has 0 internal resistance. If these two are connected in a circuit, ideal voltage source and capacitors are connected in a circuit. We know that the time constant of circuit is RC. But here the value of resistance is 0, time constant is 0. If time constant is 0, then an ideal voltage source will charge ideal capacitor within zero time, that is instantaneously. Correct option is 2. Next question. Given the internal impedance of electric circuit is 3 plus 4j ohms, for maximum power transfer, what should be the load impedance? For maximum power transfer, load impedance is equal to complex conjugate of source impedance, that is ZL is equal to ZS star. So here source impedance is 3 plus 4j complex conjugate. Now the load impedance should be 3 minus 4j. Load impedance is 3 minus 4j ohms. Correct option is 2. Next question. In an electric circuit, series impedance consists of 3 ohm resistance in series with inductive reactance of 4j4 ohms. If the circuit is energized by a AC voltage source of 50 sin 100 pi t, then what is the current in the circuit? So here the impedance Z is 3 plus 4j. So magnitude of impedance is square root of 3 square plus 4 square. So that is 5 ohms. Total magnitude of voltage is 50. Now the magnitude of current is 50 by Z, 50 by 5, that is 10 ampere. Now the given circuit is RL circuit. In inductor, voltage leads the current. Voltage leads the current, that is current lags by voltage. The lagging angle is phi is equal to tan inverse imaginary component by real component, tan inverse 4 by 3. So that is phi is equal to arctan of XL by R. So phi is equal to arctan of inductive reactance by resistance. Now the current I is 10 sin of 100 pi t minus 5. So that is 10 sin of 100 pi t minus tan inverse 4 by 3 ampere. So correct option is 1. Next question. A two-port network is defined by the relation I1 is equal to 2V1 plus V2, I2 is equal to 2V1 plus 3V2. Then Z parameters is. So given Y parameters, admittance parameters or short circuit parameters. So here admittance matrix is 2, 1, 2, 3. So the relation between Y parameters and Z parameters is Y is equal to Z inverse or Z is equal to Y inverse. So to find the inverse of a matrix, 2 by 2 matrix ABCD, so inverse is 1 by AD minus BC, D minus B minus C comma A. So apply the same matrix inversion here. Then we will get Z parameter Y is equal to 1 by AD minus BC, 2 into 3 minus 1 into 2, and then D minus B minus C A. So we get, in the question they ask to calculate Z12. So Z12 is 1 by 6 minus 2, that is 1 by 4, and the element is minus 1. So Z12 is minus 0.25 ohms, minus 0.25 ohms. Question number 81. The Fourier transform of unit impulse function delta of t. So Fourier transform of unit impulse function delta of t is 1. So similarly, shifted impulse function delta of t minus t naught is e power j omega naught. So here correct option is 3. Next question. What is the Fourier transform of convolved time domain results of two functions whose individual Fourier transforms are x of f and y of f. So Fourier transform of x of t convolution y of t or h of t. Y of t is x of f multiplied with y of f. So that is convolution in time domain is multiplication in frequency domain. So correct option is 3. Z transform of unit impulse function delta of n is 1. So that Z transform of delta of n value is 1. So correct option is 4. So other Z transforms are given. Z transform of u of n is 1 by 1 minus Z inverse for mod Z greater than 1. Z transform of minus u of minus n minus 1, that is for non-causal signal, is 1 by 1 minus Z inverse for mod Z less than 1. Z transform of a power n u of n is 1 by 1 minus a Z inverse for mod Z greater than a. Similarly, Z transform of minus a power n u of minus n minus 1 is 1 by 1 minus a Z inverse for mod Z less than a. Question number 84. So to find which of the systems are LTI systems, non-causal LTI systems. So h of n is u of n minus 4. Here present output depends on past input. Present output. So keep n is 0. H of 0 is u of minus 4. So present output 0 depends on past output minus 4. So present output depends on past input minus 4. Here put n is equal to 0. H of 0 is u of plus 4. So that is present output depends on future input. So present output depends on future input is non-causal system. Present output depends on past input is causal system. Similarly, h of n is delta of n minus 3. Here also present output depends on future input. Therefore, non-causal system. You put h of n is 0, u of 0, u of minus 1. Here output depends on past present input as well as past input. Present input, past input. So hence it is a causal system. In option 4, present output depends on past input as well as present input. It is a causal. In the question they have asked which is a non-causal system. So option 2, 3 are non-causal systems. Next question. Unit impulse response of LTI system is delta of t. So here input is u of t. So let us assume input as Laplace transform of let us assume input as p of x of t. Laplace transform of input, that is Laplace transform of x of t, is x of s. X of s is Laplace transform of u of t, that is 1 by s. And the impulse response h of t is delta of t. Laplace transform of impulse response h of t is transfer function h of s, that is Laplace transform of delta of t is 1. Now the output y of t is we need to calculate. So we know that y of s is x of s into h of s, that is 1 by s into 1 by s. Now y of t is inverse Laplace transform of y of s, that is 1 by s. So output y of t is also u of t. What will be the response for the system if input is ramp? If x of t is ramp signal, that is r of t, input x of s is 1 by s square and h of s is delta of t, that is 1. Now y of s is 1 by s square into 1, that is 1 by s square. Now output y of t is inverse Laplace transform of output y of s, ramp signal only, r of t. So for LTI system with impulse response delta of t, then the response of a system for ramp input is r of t. Question number 86. For a linear time invariant system, the commutative property dissips. So the properties of LTI system are commutative, distributive and associative properties as mentioned in below the question. So commutative property is x of t convolution y of t is y of t convolution x of t, both are same. So correct option is 1. Question number 87. The poles of transfer function is given as. So we know that poles are roots of denominator transfer function. So given transfer function is s square plus 4s plus 4. The roots of denominator is poles s square plus 4s plus 4 is equal to 0. Solve this. S plus 2 whole square is 0. S is minus 2 comma minus 2. So the roots are minus 2 comma minus 2. Repeated pole at minus 2. Out of the following materials, which one will have maximum forbidden band gap? So this forbidden energy gap or band gap is the difference between top of the valency band and bottom of the conduction band. Energy gap is EC minus EV. EC is minimum energy of conduction band, EV is maximum energy in the valency band. So for aluminum, which is a metal, here energy band gap is 0. For silicon, germanium, these two are semiconductors. For silicon, energy band gap is 1.1 electron volts. For germanium, it is 0.66 electron volts. For silica, which is an insulator, energy band gap is 5.5 electron volts. So in conductors, this valency band and conduction band both are merged. So EC minus EV is 0. It is energy band gap is highest for insulators. So correct option is 4. Question number 89. The current flowing through a semiconductor due to application of external DC voltage, it is called drift current. So this drift current occurs when charge carriers move under the influence of external field. So diffusion current arises due to difference in charge concentration, that is diffusion current is due to gradient of electric charges. So there are two currents in semiconductor, drift current and diffusion current. A spherically shaped section of n-type silicon has 2 millimeter length and 0.2 millimeter square cross sectional area, calculates its resistivity when it is a pure intrinsic material. So given silicon, this question is deleted because the resistivity of pure silicon, intrinsic resistivity, doesn't depends on material dimensions. Intrinsic resistivity for pure silicon does not depend on material dimensions. So its value is 2.3 into 10 cube ohm meter. No correct option. And for germanium it is 4.6 into 10 power minus 1 ohm centimeter. For silicon it is 2.3 into 10 cube ohm centimeter. Silicon has higher resistivity than germanium, meaning silicon has poor conductor in intrinsic state. Silicon is poor conductor in intrinsic state when compared to germanium. Question number 91. The voltage required to forward bias a PN junction based on silicon is 0.7 electron volts. So the junction voltage or breakdown voltage, cut-in voltage, junction voltage or cut-in voltage or threshold voltage for silicon is 0.7 volts. For germanium it is 0.2 or 0.3 volts. So here correct option is 4. Next question. It is related to Zener diode. Calculate the minimum current that can be passed through Zener diode. So minimum current is power dissipation by Zener voltage. So power dissipated is 400 millivolts and the Zener voltage is 7.5 volts. So its value is 0.0533, that is 53.33 milliampere. Correct option is 1. Next question. Mass capacitors are widely used in dynamic RAM. So dynamic RAM uses capacitor and MOSFET as a MOS transistor as a storage cell, whereas in case of static RAM, 6 transistors are used to manufacture a single cell. So this DRAM is slower, cheaper, and the density is higher, whereas SRAMs are faster, more expensive, and lower. So mass capacitors are widely used in dynamic RAM, that is DRAM. Question number 94. In common gate MOSFET amplifier, the phase shift between input and output is. So we know that in BJT, the terminals are emitter base collector. Similarly for FET, the terminals are source base equivalent to gate and collector equivalent to drain. And common configurations are common emitter configuration, common base configuration, common collector configuration. In FET, common source configuration, common gate configuration, common drain configuration. In this common emitter configuration and common source configuration, it introduces 180-degree phase shift between input and output, whereas common base, common gate, 0-degree phase shift, common collector, common drain, 0-degree phase shift between input and output. 0-degree phase shift between input and output. So in the question they have asked common gate configuration. For common gate configuration, the phase shift between input and output is 0. Next question. Typical forward bias voltage of LED is, it is around 1.6 or 2 volts. Question number 96. For a maximum output power, the solar cell must be operated at. For maximum output power, The solar cell must be operated at maximum power point. So this maximum power point is also called knee point, knee point of its VI characteristics. And this new knee point exists in between. This knee point condition or maximum power point condition exists in between open circuit voltage where voltage is maximum, current is 0, short circuit current where current is exist and the voltage is 0. So it is in between open circuit voltage and short circuit current. At the knee point voltage is maximum, current is maximum, therefore power is also maximum. For a maximum output power, the solar cell must be operated at knee of its VI characteristics, but not short circuit condition, but not open circuit condition. Question number 97. An illuminated photodiode without external bias. So that is generally these photodiodes are operated in reverse bias. It converts photons to electricity. If there is no bias given to photodiode under no bias condition, it acts like a solar cell, that is photovoltaic mode. Photovoltaic cell. So photovoltaic device. If photodiode is connected in reverse bias, it converts photons into electricity. If photodiode is connected in forward bias, what happens if photodiode is connected in forward bias? It acts like a normal diode. If photodiode is connected in under no bias condition, it acts like a solar cell or photovoltaic cell. Under forward bias condition, it acts like a normal diode. Under reverse bias condition, it converts photons into electricity. Correct option is 1. Next question. The main purpose of oxidation in IC fabrication process is, the purpose of oxidation in IC fabrication is, one is passivation, and it also serves as an insulating layer. Passivation and insulating layer. Correct option is 3. So passivation means it protects the silicon from contamination, moisture and physical damage. Next question. Diffusion process in IC fabrication is done by heating the wafers in atmosphere of impurities. So diffusion process is used to introduce dopant impurities. For diffusion to take place, silicon wafer is placed at the high temperature furnace. Gas and vapor containing dopants are introduced into the furnace. Dopant atoms diffuse into silicon wafer due to high temperature. So correct option is 1. Next question. The epitaxial growth allows the wafers to be dashed by diffusion process. During epitaxial growth, dopants are introduced. Epitaxial growth allows the wafers to be doped by diffusion process. Correct option is 3.